Welcome back to Educa site. We are moving the course to the further. I hope you have got the notification by YouTube on your email ID about this video. If you have not got, then click on the bell button below so that you will get the email by YouTube whenever a new video is uploaded. So be first to watch the video. In the last lecture, we learned about number system. Today we will classify number system. Basically, number system is classified into 4 types. That binary, decimal, hexadecimal. Can you guess the last one? Yeah, it's octal. So if you we will begin with the most easiest one, that is the decimal system. Decimal system is a normal system that contains numbers from 0 to 9. So let's take an example of 11. Suppose we want to write a number 11 in decimal number system. We will write simply it as 11, 1, 1. The same number we want to write in binary number, but in binary we have only 0 and 1s. Isn't that? Only 0s and 1. So how to write 11 using only 0s and 1s? It's very simple. Binary number consists of, for instance, we will take a 4-bit binary number. Bits can be increased as per your need. I hope you remember the bits. 1 is a single bit, 0 is also a single bit. So, to write 11, we will write it as 1, 0, 1, 1. I know you are not getting this. Let me explain you. Before all, this is called as least significant bit, and this is called as most significant bit. The rightmost is called as least and leftmost is called as most, as it holds the least decimal value and it holds the maximum decimal value. How it goes? The rightmost is the unary number 1. This is the decimal number 1. Then double of it 2. Then double of it 4, double it of 8, and so on. You can go on. Just go on doubling the number and you will get its equivalent value. So here it completes the 11. 8 plus 2 plus 1. Here if you want to convert it in decimal, it will look it as 8 plus 0. As 1 is for on. In the most of the compilers, it is used as 1 is for on and 0 as off. This is universal method, but not necessarily it will be in all the compilers, but most of the hardware and compilers use these things. So in similar manner, we will follow that. 1 is for on, so 8 plus 0 plus 2 plus 1. That makes our 11. So I hope you have understood how to write any number in the binary number. It's pretty simple. 1 and then double of it 2, double of it 4, double of it 8, and so on. You can go on till the number of bits you want. It depends on the number of your decimal number. It depends on your decimal number. Now coming to the hexadecimal. Hexadecimal is simple, 0 to 9 and A to F. Nothing special you need to write. 11, 0 to 9 as normal. Then 10 will be represented as A, 11 as B, 12 as C, and so on. So you might have known 11 will be written as B in the hexadecimal number. Look at this. This is the most important thing. This is the base. If you forgot to write the base, then the conveyor or whoever is reading it will not be able to know or will not be able to judge in which form the number is written. For example, if you forgot to write 10 over here, then maybe he can consider it as a 2-bit binary number. So its decimal equivalent will be 3. That is totally different, but we want 11. So that's the most important thing, base. You must not forget to write it. Octal. Octal consists of 0 to 7. But basically in octal number system, to convert the decimal number, we separate the number into digits. So 1 will be separated as 1 and 1. 11 will be separated as 1 and 1. We will write binary equivalent of 1, that's 0001. I hope you got that 0001. The least significant bit is 1, then double of it, then double of it, then double of it. But these are all off. So 0 plus 0 plus 0 plus 1. That's it. And then 0001. That's the octal equivalent of 11. That's pretty simple, isn't it? But octal number we use is in very rare case. It's not used in much cases because it's difficult to write, convey 9, 10 such numbers through octal numbers. Therefore, we use it rarely. The main numbers are binary and decimal numbers, which we'll be using most. We will use binary and decimal number frequently. So I hope you got it clear to the simple conversion from decimal to binary. We will take one more example. Let's take an example of 22. So to write 22, we will calculate 22, 8 plus 4, 8 plus 2, 10. We will need more bits, right? We got need of 16 also. So 16, 8, 4, 2, 1. 16 plus 4, 20 plus 1, 21. Yeah, we got that. So 16 pay 1, 4 pay 1, and 1 pay 1. Okay, another 0. That's our binary equivalent of 21. Don't forget to write this. This is the most important thing. This is the for our virtual concept, so you should never write this or anywhere. I will bracket it out. Don't use this thing anywhere. Actually, it should be in your mind. Okay. On board, on screen, which you will see on paper, which you will write is these things. Don't forget to write the base. Base is here too. That signifies the binary number. So anyone will read it as 21. Okay. The message will be conveyed properly. Okay. So let's learn more methods of converting decimal to binary. This is the one simple method. Let's switch over to another method. The second method to convert decimal to binary is pretty much longer, but used at many places. It's called as double method. Double method. In short, we will say it as DDM. So in double method, the thing is very simple. We will understand it through an example. We will have to divide the number and then we will have to take the remainder. You will get it when we will do the sum. So let's take an example of suppose 29 to be base 10. What will be its base in decimal system? That signifies it's a decimal number and we want its binary equivalent. So in double method, what we do is we will divide 29 by 2. Why 2? Why only 2? Decimal number system consists of 2 bits. First thing. Second thing, in decimal number system, we will, while converting it to extremely sorry. Why only 2? First of all, binary number system consists of 2 bits. The second thing is, by converting binary to decimal, we have seen that we are double it everyone. That means we take it as 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 and so on. So that's why the number 2 is important to us. So we will divide by 2. So 29 divided by 2 will get us 2 2 minus 0, 9. Here we got our first remainder. We are not concerned with the quotient. Reject it. Take the remainder out. 1. Then divide the remainder out and take the quotient to the down, which will be the divisor of another division. Again the dividend will be 2 only. So 2 divided by 14. Here we go. 7 to the 14 minus then 0. Take 0 out. Take 7 down. We'll again divide 7 by 2. we will get 3 to the 6 minus 1, take 1 out, divide 3 by 2. Continue till we get the question 0. 2 and the 2, 2 minus 1, take 1 out, get divide 1 by 2. Here we got the question 0. Minus 0, 1, take 1 out. So here we have got 1, 2, 3, 4, 5, 5 remainders. So that means our equivalent binary numbers is 5 remainders. So that means our equivalent binary number is of 5 bits. Now this is the last number which we got is our most significant bit, and the first number we got is our least significant bit. So hence naturally the number will go from most significant bit to the least significant bit if you are reading from left to right. So left to right we will write it from most significant bit to the least significant bit. That goes it as 1 1 1 0 1. So equivalent binary number will be 1 1 1 0 1. I hope this method is clear. This is known as double method. These are the two primary methods. We don't need to study other conversions as such. You can convert it by binary number into other forms as taking binary its equivalent decimal, and you know how to convert decimal to any other form. So that's it. Take it out anything to the decimal and convert it as you want. We have learned two methods to convert binary to decimal, and decimal to binary is very easy. That we learned the most common method 2 to the power 0, 2 to the power 1, 2 to the power 2. You can take the equivalent values of the binary number taking the on switches, assigning these equivalent values to the on switches, and on the off switches assign the value as 0. From left to right you will get your equivalent decimal number. As easy as that. So that's it for now. Thank you very much. Do whatever you want, but keep learning.